Today is Tuesday, June the 11th. The Dragline's making its second from the last cut in the south end of the pit. We're just about finished stripping here. The Dragline picks that dirt up and dumps it approximately 255 feet away from the center line of the machine. The machine has a 285-foot boom, 76-yard bucket. The boom's setting at a 38-degree angle. That gives it 255 foot of reach from the center pin of the machine. However, there are links on the A-frame, and they're distinguishable if you watch when it gets in profile here, up near where the mast pins to the gantry. Those links, by moving those mast cables into those links, it lowers the boom to a 32-degree angle, giving it approximately another 15 feet of reach. When he swings over again, I'll try to show you those links that are on the gantry. Now that's the links that you can pin those mast cables into. The machine weighs 7 million pounds, that's 3,500 English tons. We're digging a pit right now about 100 feet wide. That's a little wider than we normally would dig, but with the low cover we have here and finishing up so that we can end up with one more cut here, we're taking a little bit larger cut than we normally would. The drag ropes and the hoist ropes are both 3 3/4 inches in diameter. The dump ropes are 3 3/8 in diameter. The machine originally was designed for 3 7/8 drag cables and 3 5/8 hoist ropes. But early in its career we changed that so that we could use 3 3/4 either place. What we've done on several occasions is run the hoist ropes to about 4.5 to 5 million yards, then taken them off, put new on, and used the old hoist ropes, cut them shorter in the proper length, and used them for drag cables. This has worked out fairly well. There's been several occasions where we left them on too long and didn't get much drag life out of them, but on several occasions it's worked out quite well, saving the cost of the drag ropes. Probably getting an extra 2 million yards out of the ropes on the machine. The machine's in fairly good shape right now. There's some problems with the rails and rollers. They're original. They should be changed within the next, well, if it's going to be used again for any extensive period of time, when we shut down before it started again, they should be changed. The segment gear also that the swing rack, that mounts to the swing rack, where the swing pinions run, they also should be changed. They've been changed once, about 1988, something like that, but there's several cracks and they need to be replaced. Also, the top of the tub is cracked in several places, as is the vertical support under the circle rail. Now, on many occasions in the U.S., the tubs on some of these machines have been replaced. I really don't feel like that's necessary in this case, but they definitely should be some time spent welding in them. I would imagine something in the neighborhood of several hundred hours of welding, man hours of welding would say I'm thinking maybe 300-400 hours of welding should take care of the tub. What he's doing now, he digs the pit cut, puts it of course on the bottom. It's better material, the shale and rock. Builds his buck wall on which he'll place the loose unconsolidated material, the glacial till, on top. We also here swing on around after we do our lower bench and take the very top 6, 8, 10 feet of dirt and put on top for a root media to grow crops in. This is all prime farmland and it has to be returned to 100% of its pre-mining productivity. The regular operator isn't operating right now. The oiler's running the machine and he's just a trifle slower, but he is in fact quite smooth, as you can see. But this is a very well balanced machine. That is, the drag, hoist, and swing speeds are all very close to being the optimum. It's very rare that when he swings around that he is waiting on his drag or hoist. This particular pass he's making there, he's trying to cut that keyway to keep his high wall straight. If you can notice there just slightly, his high wall is pulling in towards the right as we're looking at it. The operator sits in the cab there on the right side of the machine, right there. Can't quite make him out because of the glass in the cab window. The fair leads on the machine were repaired not too terribly long ago. There's a couple new horizontal sheaves on there, and the vertical sheaves are in fairly good shape. The machine has a crew of 3 men, the operator, who controls all the motions including the propel inside the cab, the oiler, whose job it is to go around the machine inspecting for hot bearings and that type of thing, being certain that everything's getting greased and lubed like it's supposed to, and the groundman, who, using an iron tractor, a dozer, builds road for the machine. That's what the gentleman's doing over here to the left. Trying to shade this lens a little bit with my hand, and a couple of times my hand's gotten into the picture, I'm afraid, but the sun is just so that I've got to shade it in order to keep it from glaring. Out of the pit, digging the shale, most of the operators, even the oilers, will make a swing about every 40-45 seconds. Occasionally he might get over 45, maybe into 50, maybe even a minute, but then he'll have several down in the high 30s also. So he averages about a bucket every 45 seconds out of the pit. Now when he starts digging bench, it's nearly twice that long, simply because of a longer swing. The bench, of course, the bench material doesn't dig as hard, but it sometimes dozes ahead of the machine and the bucket, and doesn't load the bucket as well. That's a pretty good bucket of shale there. Just about level full, that'd be about 76 yards. I'm going to tilt the camera down just a little to get away from that sun glare. We may not be able to see the point of the boom, but we'll be able to watch him dig. Alright, I'm just going to let the camera run there a while. Looks like they're changing operators now. This will be the regular operator getting back in the seat. You'll probably notice him fill the bucket just a little fuller, and he'll also swing the machine just a little faster. Most of our operators will move somewhere in the neighborhood of 3,000 to 3,200 yards per hour, and the machine runs with all of our delays included, including the operational delays such as changing cable, passing the drill, down to shoot, down to pass the loader through the beneath him so that they can load coal where the back this way, that type of thing. Everything added, that plus the electrical and mechanical delays amount to something in the neighborhood of 37% of the time. So we have something in the neighborhood of a 63-64% digging time. The deeper the digging is, the better the digging time is, because he spends less time moving. Now he's about to move now and walk back toward his face so he can reach the bottom of his dig without dragging his cables in the roll. So we're going to zoom in and watch him as he propels, and I'll try to explain what's happening. The large walking mechanism on each side they call a shoe, and in that frame, that's oblong looking frame with a vertical slot in it, there's a cam that rotates. And as the cam rotates to the rear, it sets the shoe down to the rear, then as picks up some weight of the machine, tipping the machine up on the front edge of the tub, and sliding it back, then picking the shoes, setting the machine down and picking the shoes once up, once again, in the original position where they dig, which is right now. Now you'll watch as the machine, I'll try to zoom in and show you the machine rising. Well, I guess you can't really tell too much from this distance. Machine raises, slides to the rear, sets back down very gently, then the shoes raise again. That's how the machine actually propels. It walks in effect. Now he's taken 2 steps back so that he can better reach the pit without dragging his cables in the roll at the top of his dig. Going to swing around now and start digging again. And as I said, he'll be able to reach a little better now without getting his cables in the roll. Once again, I think I'll just leave the camera on him. I don't think any narration is necessary. Swings around. Once again begins to dig in the pit. As I said earlier, this operator will fill the bucket a little fuller. Now that's, in that short cut, that's a pretty good bucket full. The noise you'll be hearing in the background is this dozer that's building the road to make the next pass with the dragline. Good hefty bucket of shale, just about as full as you can get it without running it off the back end. Alright, I'm going to turn the camera off now. I'm sure everyone would get the idea of what we're doing here in the shale. And then when he starts benching, I'll try to record some more of that. Once again, a real fine load of shale right there. Okay, the dragline's benching here. Benching, that is, he picks up the upper part of his overburden. It's glacial till or drift or whatever you want to call it. It's unconsolidated material, primarily sand and gravel and clays. The lower part of this he puts over on his spoil right above his buck wall. He pulled the buck wall down flat. Then he puts this over there. And then after he gets it over there, he levels it off, and then in turn puts the upper part of the bench material on top of that to form the root media. You can see that where he's putting that. It's pretty soft material. It dozes ahead of the bucket. Sometimes it's a little difficult to get a good bucket full, but when you do get a bucket full, you really got a lot of weight. Now that there's a pretty good bucket full. Yep, see, he lost the big chunk of it off the front. You'll notice here that his times from his swings is quite a lot longer, and that's simply because it takes a little longer to fill the bucket, and of course it's further to swing, taking a little bit more time. It's a dandy machine. See, he's losing a lot of it out of the front. Hard to get a good big bucket of that stuff when you don't have anything to pull it against to load the bucket. It kind of dozes ahead of the bucket instead of sliding back into it like you'd like it to. See, that was only about a 50-second swing. That's pretty good time off of that bench. But then he didn't have much of a bucket full. Now he's going to try to cast out. Get a little bit better bucket full this time. difficult to see, but it looks like it's dozing ahead so bad. That's why they end up with the bench being a little lower there. They kind of tend to dig a hole so that they can get the daggone bucket full. So it's got something to shove against. Well, I'm going to shut the camera off now and go down to get ready when he moves so that I can get good pictures of them propelling. Alright, we're going to try to get a good picture now of the propel mechanism. You can see the cam. See the cam rotating. Setting the shoe to the rear and down. Then as the cam continues to rotate, it picks up the back of the machine ever so slightly, continues to rotate, sliding the machine back, set the machine back down again, very gently. And then as it continues to rotate, it picks the shoe up off the ground again, ready to do the same thing again. That's actually how the machine travels from one place to another. That's how it's propelled.